Okay, so hello everyone. In this video, we will discuss almost everything about pointers, double pointers, arrays, 2D arrays through this single problem. So this problem consists of a detailed understanding of everything. So first, I would suggest you that you should try this on your own and keep watching to learn a solution for this, and this will just not for its solution, but this will clear all your concepts regarding these topics. So let us just start. So first I would like to make you understand what exactly the question is. So we have a matrix, 2D matrix. I'm assuming you know that a 2D matrix look like this. So it is basically arrays inside array, a series of arrays. So it is a 2D array. So I am assigning a new variable in star pmat equals to, I am typecasting this matrix. So our preliminary idea says that matrix and array are both same, pointers and array and all are same, like, isn't it? So what is the need to typecast this basically? And also, why does printing the address gives 1 and why are all these equal? So these are bit advanced things which we will discuss today by the end of the video. But first of all, the preliminary idea I would like to give you is what we all learned. Pointer is a variable which stores address, right? So do you think would it be always true? So uh, we will clearly discuss this. Why is it not always true? Which cases it are true? It is true. So first first of all, like, I would like to differentiate between what exactly is arrays and pointers. Like, first, they are always taught like arrays and pointers are both treated identically, but are they exactly the same? I mean, are there are any noticeable difference at all? So do you think we can perform everything with array and star array identically? With an array and a pointer of same variable, can we perform everything identically? So let us just dig a bit deeper with the help of an example. The purpose of writing this code is to I want to swap the basically two characters of a string with two given indices. So this is my name. I would like to swap the indices present at 3 and 4, and I am calling this function, then I am printing the string, and nothing works actually. So first I would like to tell you, pause the video and think why this code is not working at all. I have written everything so nicely and it is passing value by reference. Of course it is passing value by reference. I am not assigning any new pointer inside the variable. I am not returning anything. So why is it actually the code is not running? You can run and see it and try to understand. So it does not work when we give star, but the same code if I write with str this array, it works perfectly. It works smooth as fuck. So right, what exactly is going on? Let us understand this. So this char star and char array are actually different types, but it is not immediately apparent in all cases. This is because arrays may decay into pointers. So first misconception which you have to remove to get a clear understanding of pointers is that array and pointers are not same. Arrays decay into pointers. Arrays and pointers are totally different. They decay into pointers, meaning that if an expression of the type char is provided where one of the type char star is expected, the compiler automatically converts an array into pointer to its first element. So the array, if we want to reference it as a pointer, the compiler automatically decays that array into the pointer to its first element. But with these two codes, by running these two codes, it is clearly apparent that they are not identical, because this works perfectly and that doesn't work. So now I would like to introduce you to a bit of mutable and imputable data types. You know that If you know about Python, a much simpler language, actually it is much simpler from the basic perspective. It was there in the CBSE board, so you should know it. And actually what happens, the list are mutable data types. Mutable means, actually what happens, there is nothing called lists in C. We have to do linked list. So what actually is the case, like lists, we can alter the elements of a list, we can change the elements of a list, but a string we cannot change. So we say that string is immutable and lists are mutable. We say like this in Python basically, so you don't need to think about that. So what here exactly is going on is that when we reference as char star, we are referencing basically a string, that is a pointer, and strings are always immutable form, you know that. Strings are immutable form and hence it doesn't work. But we reference char, it is simply an array, right? And we know that all arrays are always mutable. So this is exactly what is the difference. So another difference between array and pointer is that array has a predefined memory but pointer doesn't necessarily. For example, we define an array by array 5, but when we are like int array 5, we are initiating it like this. But for pointer, we are just writing int arr, we are not specifying how much memory it will consume. Same for 2D array, we are just giving double pointer and maybe giving another row, but we are not specifying how much memory it will occupy. So it doesn't have memory allocated to them from beforehand. So by now one thing must be crystal clear to you, that arrays and pointers are not same. So before this video maybe you thought both are exactly identical and we can perform everything. So now one thing it is clear that they are not exactly the same. So now we can go here and understand easily why matrix needs to be typecasted, because this is a pointer, double pointer, but matrix is not a double pointer. It will give error if we write only matrix. So basically what is the case is that matrix is a 2D array, we are referencing it to as double pointer, so we need to typecast them. So let us just see it here. I have written that 2D array is not equivalent to a double pointer. 2D array is equivalent to a pointer to arrow different. Therefore typecasting of int star star matrix was necessary, and pointing to storing address of are a different thing. So first of all, when we approach to solving this, what will click to you basically? What is star matrix? Star matrix is the row. What is matrix? Of suppose first I give you any array, let's say it's 5, 4, 9. A equals to any array, then you know that A basically is a pointer to its first element. So similarly matrix is a pointer to its first element, and this first element is itself a pointer to 1. So can we say it like that? The matrix stores the address of the first element, and the first element in itself stores the address of 1. Then matrix stores the address of 1, and star matrix stores the address of 1. Star matrix is basically this value at address, right? So here comes the trick. We cannot say it like this. This is the case when a pointer does not necessarily store an address. So when will it exactly? So let us just find out. So one thing must be clear to you is that what is star x? Star x does not always necessarily means value at address, but it always means where is x pointing to. So what does this exactly have? What exactly I have told it basically? So suppose I am giving you a pointer variable x which is pointing to y. Y itself is another pointer variable which is pointing to z. And if we define the address of y is in x, the address of z is in y. If you always stick like this, then what would happen is why the address of y is not defined. Can it be possible ever? The address of y is not defined. So our matrix was x basically, and matrix is pointing to our first row, and the first row is pointing to 1. This is the case where this address is not defined. So first of all, let us see what do I basically mean. So pointer to pointer is possible, called our pointer. So this is just the definition. So now pointer is just a variable with store address and nothing more than that. Okay, it's just a variable with store address. Remember, it is a variable with store address. I cannot blindly say it will always store address. We need a variable for storing the address. So first of all, address of address is not possible in a direct way. We cannot say address of matrix 1 is the address of 1. So what can we say is, this I told you this does not work. Why? Because, but if you do something like this, it will work. Like int star k address of this, and then we print address of k. So this is also basically address of matrix, but it works. But it will works very nicely. But if you just run this, it won't work. The code will stop abruptly, or it will give an error. But this is because the value is printed here is an address of variable k. Remember it. This is not an address of any intermediate thing. This is address of variable k, and the address of variable k makes sense because the address of matrix does not make sense. Okay, so only those things have address which have memory allocated to them. Okay, so I told you that here 1 2 3, the address of 1 2 3 does not make any sense. So why it does not make any sense? Because it does not have a memory which is allocated to them. Now what am I saying? Then where is it storing? Where, if it is not, if it doesn't have any memory allocated to them, where exactly it is storing? Where exactly are these things storing? So it has actually, but let us see what is the case. Now I told you basically why was in star typecasting was necessary. Now you think like this. You don't think about the address. You see matrix is a pointer pointing to this. You don't tell that matrix is storing the address of this. Okay, this is the first misconception which you need to remove. Storing address and pointing are totally different. This is a pointer pointing to 1. Therefore matrix also points to 1. Matrix basically points to 1, and it works like the pointer to pointer way and not the address of address way. The double pointers basically works this way. You cannot say address of double pointers. You can say pointer to pointer. If you say matrix stores the address of 1 2 3. Okay, so matrix is address of 1 2 3. If you say this way, the wrong way I am just saying address of 1 2 3. 1 2 3 is address of 1. Then what will you conclude? Matrix is of address of 1. Address of 1. With these two things which you will conclude is totally wrong. Double pointer does not work this way. Okay, so I am removing this. This is totally wrong. So there is a lot in this video left out still. So why it, so here both matrix and star matrix stores the address of 1. You can see matrix also points to 1, is points to 1. Okay, so it simply means where is the matrix pointed to. Here star matrix does not means the address of 1. This is the main thing of the entire video. The star matrix does not means the address of 1. It simply means where is the matrix pointing to. Now I said you that address of 1 2 3 is not defined. So here you will get to see why it is not defined. A 2D matrix is stored in memory something like this. Suppose these are the elements of the memory. Now these are the address of the first 100. Let's say the address is 100 and the fourth element address is 112. So this is the basically first row and this is the basically second row. So if I ask you what is the address of 1, 2, 3, does it make any sense? Does it make any sense at all? What is the address of 1, 2, 3? So looking at the memory block diagram, what is the address of 1, 2, 3 does not have any meaning. But if suppose a equals to 1, 2, 3, then a equal to 1, a 1, 2, 3 array has an address that is due to the variable a. That is entirely due to the variable a. So in the statement pmat equals to in star star matrix, so basically what we are doing here, we are just typecasting it. So pmat equals to matrix is equal to address of 1. I told you because matrix is pointing to 1. Pmat is assigned the address of 1. Pmat is basically assigned the address of 1. Better to say pmat is pointing to 1. Pmat is pointing to 1 and hence star pmat is 1 and star star pmat is undefined. Why star star pmat is undefined? It is pmat is just a variable which is assigned the address of 1. Pmat is not any proper matrix. Pmat does not have the memory allocated to them to store all the elements of a proper matrix. All we know is that pmat is a double pointer which stores the address of 1. Matrix is basically the address of 1. Why it is the address of 1? Because I explained you detailed here. Matrix points to 1. So matrix is also the address of 1. So also clearly you can visualize this thing. Also I will show you by pointer algebra how this thing works exactly, or you can understand basically this is basically the star matrix, the address of the first element of the matrix, but this is not exactly the matrix, and this thing is a bit illusion. I would say you, because pmat is not any proper matrix. You cannot just keep on accessing the elements of p1. The code will keep on stopping abruptly. Won't work at all. So now you should argue that pmat and matrix are both 2D arrays, but matrix equal to star matrix equal to address of 1, basically address of star star matrix. So it is basically address of 1. So but both are 2D arrays, right? But now I would like to say you, I would like to reiterate one thing again, that pmat is not any proper matrix. It is just a variable which is being addressed as star pmat. So for this you must know that pmat is not any proper matrix, neither it has any allocated space to itself like a 3x4 matrix. So pmat of 0 0 is not defined too, but matrix of 0 0 is defined. But through the statement pmat is assigned as, so the only thing which we could comment is star pmat is 1. If you have doubt in how this equal to star pmat, if you have doubt in so we can prove it by pointer algebra calculation. So this is a very useful calculation. You can apply it everywhere. So you know AB is lexically defined as star of A plus B pointer. This is pointer addition, remember it. This is pointer addition. Pointer addition means P plus 1 means increments the pointer basically. P plus 1 means wherever P is in a memory, you move one memory block forward. This means you move one memory block forward, adding of 1. So this is what basically pointer algebra means. So you can write this portion. I am taking basically, I am taking this portion and applying the formula. I will get this. You move 0 memory block forward means you stay at the same place. Then you put the bracket, and you know that R and ampersand and star are just the opposite. So you can write just pmat 0, or it is equivalent to star pmat, which is equivalent to 1. So now you have enough information to reason out all these outputs. So you can go on one by one. These are the, if you give these are the inputs, you can just pause the video and just have a look about the outputs. This is for your own practice. It will be a very good practice for you, I would say. I would recommend to pause the video and just make out. Also there is a trick here why this happens. So basically in one place I am addressing a variable, and in the other place I am not addressing anything at all. So that's all, yeah, from this video. Hope you have learned something new, and If your idea of pointers and double pointers did change completely after watching this video, don't forget to mention it in the comment section. Thanks a lot.